Welcome to Theory of Computation class. Here in this class, I am going to discuss the conversion of epsilon NFA to DFA problem. So the theorem says that let L is a language which is accepted by epsilon NFA, then there exists L which is also accepted by DFA, which means that you can able to convert epsilon NFA into DFA method. So what is the steps means? First, the given notation M is an epsilon NFA which contains 5 tuple representation in it. Q set of states, sigma set of alphabet symbols. It contains transition functions in it, and also it contains starting state and final state. We should construct DFA state. So MD means it is a DFA state which this should be calculated. So how can we construct those values means? First we should obtain the epsilon closure of starting state of epsilon NFA. Here this Q0 is the starting state of epsilon NFA. So in step 1, you should calculate epsilon closure values for all the states. So here I just write it, calculate epsilon closure values for all states of epsilon NFA. First you should calculate it. Then the starting state, how can you calculate the starting state of DFA means? What is the epsilon closure of NFA starting state? That is epsilon NFA starting state, which is also the DFA starting state. Then you should obtain the calculation. That means we should calculate tilde D value for the resultant answer. Here the square bracket of P1, P2, Pn is nothing but it will be calculated with the epsilon closure of starting state of epsilon NFA. This is the resultant answer. If you go for a DFA state should be written within square bracket. We already know the problem of conversion of NFA to DFA. The same procedure is applied. In that problem, DFA states will be represented within square bracket. So the same thing will be used here. So in the square bracket it is available. So how can you calculate means that extended transition formula, epsilon closure of tilde of those values, where this A is the input symbol in sigma. Then we should calculate all the values, resultant value. After that, how can you calculate the final state means? Whatever final states of epsilon NFA is available, those states will also be considered as DFA final states. So let us discuss the example. So this is the given diagram. This diagram contains epsilon flow in it. So this diagram is epsilon NFA and they are asking epsilon NFA to DFA. So the problem is conversion of epsilon NFA to DFA. This is the problem. First, we should write the given values. So how many Q's are there? 3 values are there. You write it. And how many alphabet symbols are there? 3 alphabet symbols. What is the starting state of epsilon NFA? That is Q0. What is the final state of epsilon NFA? That is Q2. Then write the epsilon closure value. This is step 1. The same procedure which is applied for conversion of epsilon NFA to NFA, the same step 1 is also repeated here. So whether the problem is epsilon NFA to NFA or epsilon NFA to DFA, those two problems you should calculate epsilon closure values as step 1. So the same procedure is applied here. So from Q1, Q1 flow is there. From Q1 epsilon flow goes to Q2. From Q2 there is no flow. So this will be ended. From Q1 to Q2 is available. From Q2 there is no epsilon flow. This is the epsilon closure values. This is step 1. Then step 2 is your starting state of DFA. That means starting state of DFA is nothing but epsilon closure of starting state of epsilon NFA. Okay, so how can you calculate it? We already know the given value. The starting state of epsilon NFA is Q0. What is epsilon closure of Q0? It is nothing but Q0, Q1, Q2. What is this? This is nothing but starting state of DFA. If it is a state, that state should be written within square bracket in DFA. Is it clear? Then step 3. We should calculate tilde D. Tilde D for which state? The starting state. What is the starting state? It contains 3 values in it. And you should calculate the answer with 3 alphabet symbols. Because 3 alphabet symbols are given in epsilon NFA. So you should calculate tilde D of Q0, Q1, Q2, 0. And then tilde D of square bracket of Q0, Q1, Q2 with 1. And also you should calculate tilde D of Q0, Q1, Q2 with 2. How can you calculate? The formula is epsilon closure of tilde of Q0 0 union Q1 0 union Q2 0. So you write it separately. Q0 0 union Q1 0 union Q2 0. So what is Q0 0? You check the diagram. Q0 0 is Q0. So epsilon closure of Q0. Comma. What is tilde of Q1 0? In Q1 there is no flow is there. So the answer is pi. From Q2 there is no state is the with 0 outflow. It is also phi. So only one state is there. That is Q0. What is epsilon Q0? It is, the answer is Q0, Q1, Q2, which is already available in step 1. So this is the DFA output state that should be written within square bracket. So the same answer is available for 0. Then you should calculate it for Q1. The same formula, epsilon closure of tilde of Q01 union Q11 union Q2 1. Q11 there is no answer. Sorry, Q01 there is no answer. Q11 Q1 is there. So epsilon closure of Q1. Q21 there is no answer. What is epsilon closure of Q1? The answer is Q1 Q2. This is a resultant DFA state. So that should be written within square bracket. Then the answer for this one is epsilon closure of tilde of Q02 union Q12 union Q2 2. Q02 no path, Q12 no path, Q22 Q2. So the answer is epsilon closure of Q2. What is epsilon closure of Q2? Q2. This is the resultant DFA state, so that should be written within Q2. So you draw the DFA transition table in which 3 input symbols are there and your starting state is Q0, Q1, Q2 and there is 3 answers. What is first answer? Q00 is, you should write within square bracket Q0, Q1, Q2. One answer is Q1, Q2. 2 answer is Q2. Okay. Then the same method which is from the conversion of NFA to DFA. The same procedure is there. So these 3 different states. This state is already available. So these are all the new states. So you write here. One is Q1, Q2. Another one is Q2. So you should calculate tilde D for these 2 states also. So tilde D of your new resultant state is Q1, Q2. So you find the answer with 1 and also with 2. Then the second new state is Q2. You should calculate it with 2. The same formula. So I directly write it. Epsilon closure of, what is Q1 0? No. Q2 0? No. So there is no answer. Then tilde of Q11 is Q1. Q21 is pi. So epsilon closure of Q1. Epsilon closure of Q1 is Q1, Q2. And then Q1 to no, Q2 to Q2. So the answer is epsilon closure of Q2. So it is Q2. So this is the new resultant value you marked here. And for this one, Q2 0 no, Q2 1 no. From Q2 to Q2, Q2 is there, epsilon closure of Q2 is Q2. So dash dash Q2. So we calculated the transition functions for DFA table. Then we should calculate the final states for DFA. What is the final state of NFA, epsilon NFA? It is Q2. So in these three states, Q2 is available. So these three states will be considered as final states. So I am drawing the diagram. So here I draw the diagram here. So there are three final states in DFA. This is state 1. This is state 2. This is state 3. Then we check it out. Self loop with 0. 1 means it goes to Q1, Q2. 2 means it goes to Q2 state. Then from Q1 to Q2, if it is 1, self loop. 2 means it goes to Q2. In Q2, self loop for 2. So this is the DFA diagram. So if you take the diagram contains only one output state for a single symbol. So this is the resultant DFA diagram. Thank you.